Okay now? Yeah. Good afternoon. Good evening, actually. Thank you for coming to Jury's in for our first actually hybrid session. After 2 years, we are back in person to do the talks. So this session is now live broadcast on Zoom, and we have about like 30 something people online, watching online. And we are going to is on actually recording, and we are going to upload it on the YouTube channel. So if you want to share it later with anyone else, you can do that. This event tonight is actually a joint event between ICorr Aberdeen and AMPP UK, and the talk will be done by Presserv and Seal for Life company jointly together. As you have already seen from the flyer, the speaker will be Dinko Cudic, Global Technical Authority from Stopaq. We are going to have an introduction by ICorr just in the next 5 minutes, and then after that, an introduction by AMPP. That Mike will do that for us. And then the technical presentation will take about 40-45 minutes, and we'll follow with a Q&A session. The people who are online, actually, they can put their questions in the Q&A section on the Zoom, and then we will go through them at the end of the session. We'll go through the Q&A questions in the room first, and then we'll continue with that. So just before I continue with this, a few slides for myself. So this is a ICorr Aberdeen branch sponsors. Just thanks for all for actually supporting us. They have been supporting us for the last few years, and without them we couldn't be able to arrange these kind of regular talks. We even managed to do all our monthly talks during the pandemic for 2 years. And with the support of our sponsors, we can continue with our hybrid form of the presentations as well. If you are interested to support us or ICorr in general, just please contact us, and we will be in touch with you in terms of different types of sponsorship that ICorr and ICorr Aberdeen we have. This is just a snapshot, I think 2 years ago, from ICorr Aberdeen committee members. Again, thanks for all of them supporting myself and the group to arrange all of these talks and other activities that we are supporting in ICorr Aberdeen. As I said, all the slides in PDF format will be available on our website for your reference later, and the recording will be on our YouTube channel, as you see at the bottom of the page. This is the program, the rest of the program for 2021, 2022. Actually, just we are here in the middle, sorry, at the top for April session. The next session, which is the last session of 2021-2022, it'll be in Palm Court Hotel with plant integrity management, and AGM will be at the same time at 31st of May. And the next session, which is not in our annual program, but it's a program that we hold every year, is Annual Corrosion Forum, which is in August, 30th of August. We are still in the phase of arranging and organizing this event. And the theme of this event is energy transition and the net zero target and renewables, and the relation with the integrity management, asset integrity management. If you are interested to speak in this annual corrosion forum, which was formerly was known as Corrosion Awareness Day, please contact myself or ICorr Aberdeen or Dr. Oli, Vice Chair, who is arranging actually the presentations and also if you are interested to sponsor for the venue, this is a whole day event, so you can also sponsor the venue if you have any proper space available. That's the call for speaker for next year, 2022-2023. You should have, if your email is registered with us, you should already have received a call for a speaker. The deadline for the abstracts is end of April, and the selection of the talks and the presentation will be done by the end of May. So if you have received the announcement, please reply if you are interested. If not, please again contact us, and we will communicate with you in terms of your abstract. And the call for speakers for annual corrosion forum, as I mentioned, is also in the progress at the moment. Just one update about an ongoing program that we are holding, Young Engineer Program. I have mentioned this multiple times in the previous talks. So this is the first time that we are holding this program in Aberdeen with 24 participants this year. We are actually doing the third session of the 9 or 10 presentations and lectures that we are arranging for young engineers. And in November, 29th of November, we are holding a competition at the end with their case study will be presented in front of panel of judges. Again, if you are interested in to participate in the next sessions, please contact ICorr Young ICorr on LinkedIn, so you will be updated by the next program, which will be in 2 years' time. So that's my introduction with ICorr. Let me invite Mike Haben from AMPP to have his slides.
All right, folks, good to be back at this again, doing live events. Just a quick introduction to the UK chapter of the Association for Materials Protection and Performance. And obviously, short into AMP, because we always do that, don't we? So, following several years of discussions between NACE and SSPC, they finally merged to become the Association for Material Protection and Performance. Prior to this merge, Aberdeen, Scotland and NACE GB, part of here, had merged to become NACE UK. We are now the AMP, it's in its AMP, you say it, I believe I'm correct in saying that, as we get told, the AMP UK chapter. So we have successfully merged and we're now starting to re-energise as we're all starting to get back to what we'd all agree is a normal life, hopefully. The AMP UK leadership, got a few members here. Rob Granger, he's the chair. Treasurer, Patrick, sitting there. He's hiding there in the background. He came in last, and myself. And we've got what we class is we've got a few actual members at large. They're just basically volunteers who help us out. I mean, we're all volunteers anyway. It's what you do for these type of groups in it. So that's where we're at. We're back. We're doing the same as yourselves. We're starting to get live events. We've got one scheduled in for the 16th of June. It's going to be for ICorr. They're going to give us a talk on the new HSE Energy Institute guidance for composite wraps. So they're going to do that. And we're also looking to get some training courses organised through AMP. So we've got corrosion awareness coming up. We've still got to get the dates arranged. Rob's going to get that arranged with AMP in the States. And then we're going to do further presentations and courses in Q3 and Q4. And as I say, it'd be good to see people again and meet people again and get back to normality. That's kind of all it is. It's just to give you a very, very brief refresh on where we're at. If there's any questions or you want to speak to us, all of our members are here, so feel free to come up and speak to us later on.
Thank you.
Thank you.
Is there any issues with the sound or anything? Anybody, any comments? Oh, okay. No, but if there was any problem, people will comment.
Sound is perfect, human.
Okay, as I mentioned, the today presentation will be a joint presentation by Presserv and Seal for Life. It will be the main presenter will be from Seal for Life, Dinko Cudic, but he will be supported with by Stuart Brenny from Presserv. So Stuart is the commercial manager at the Presserv Group UK business based in Aberdeen, Scotland. Stuart is the TA for Presserv's preservation management services and is responsible for the developing preservation plans for assets and equipment in storage and layup. He also works with operators and contractors in developing corrosion mitigation solutions for Stopaq and ICorr viscoelastic coatings for both onshore and offshore application. Currently working with both oil and gas and renewables companies to resolve difficult corrosion problems using viscoelastic coating and vapor corrosion inhibiting technology. Dinko is the global authority for viscoelastic coatings and has held senior management positions in Seal for Life Group, who own Stopaq for more than 15 years. Currently technology director at Seal for Life. Dinko is a regular presenter at technical conferences across the globe, including AMPP and the Institute of Corrosion, ICorr. With that, please put your hands together and join me in welcoming Stuart and Dinko for their presentations.
Thanks, Oman. Well, thanks everybody for coming up. And Mike said it's great to be in a room with people that are not masks on and that we're circulating the network. And again, it's really, really important. Presserv have been a long-standing supporter of ICorr, and it's really a great platform for us to communicate what's happening out there technically. And we're seeing a bit of a quantum shift just now away from traditional methods of corrosion control. And hopefully what Dinko's going to talk about today will raise a few questions as the way we see the industry developing. When I say the industry, I'm talking about corrosion in general. I'm not just talking about oil and gas. There is definitely a transition for a lot of corrosion companies that are in oil and gas over to renewables. And what we've learned in oil and gas is certainly lending itself into the renewables market. Yes, so today is what Dinko's going to talk about is utilizing of PIB coatings, which many people know as viscoelastics, wraps, some people know it as, or Stopaq, which is the market leader in that product area. So I think what you'll find, this is a technical session. This is talking about the application and the way the industry is moving. So that's really all I want to say, just to pass you over to Dinko. Dinko, I'll leave it to you to.
Thanks, Stuart. Yeah. Okay. Hi, everyone online and in the room. So yeah, viscoelastic coatings or polyisobutene coatings, as we call them. Historically, they were called viscoelastic or still are called viscoelastic, but viscoelasticity does not stop corrosion. It's the polymers that actually stop corrosion, and the selection of the polymers are the ones, that will deliver what we're looking for. And that's what I'll try to show you through the presentation. When it comes to the behavior of viscoelasticity, of course, there are benefits of viscous behavior, flow into the pores of the steel, etc. Especially when it comes to adhesion, because you can gain a dispersive kind of adhesion when you have a liquid, knowing that two solids do not stick to one another. So one has to be a liquid and the other one a solid for this bond. And then during that development, of course, how much elasticity do you want in it? How much viscosity? That's the balance that we played with to make the perfect coating. So Stopaq would be more in the viscous side, more in the fluid state, rather than elasticity, which is the more rubbery state. And we know the rubbery state, let's say the other side, butyl rubber tapes, shrinkable sleeves, and so on, they have viscoelasticity more on the elastic side. So this is the opposite, but I'll try and show more. But first, some basics, because this is ICorr. How do we protect against corrosion? How do we prevent corrosion? Mainly it starts with a selection of the right coating systems that guide us to the surface preparation requirements. Now, when I started a long time ago, I started as a contractor in rehabilitation of crude oil storage tanks. It was something none of the older engineers wanted to do. So me being the youngest got that job, the dirty one. And then 60% of that job was actually blast and paint the whole tank. And that's how I got involved. And that's when you learn, what are we doing? We're creating a roughness for the coating because of mechanical adhesion. Cleanliness comes along the way, but yeah, little by little you learn different coatings, different viscosities. How will they flow into the pores of the steel? How will that react over time? Are they drying too quickly, too slowly? Complicated world. Once you do surface preparation, create a profile, of course, we need cleanliness. The cleaner, the better. Yeah, and it was always what kind of air are we using to clean the surface? Does it have any contaminants and so on? But we have various ways of checking that. Then we get into the coating. What is the dew point? What are the temperatures of the steel? Shouldn't be too low, shouldn't be too high. We don't want accelerated curing of the coatings. And then, of course, we have to look at wind speeds, especially when you do tank rehabilitation. There's a lot of overspray and there's a lot of painted cars that that get you into trouble. I learned that one. Spend a day at the police. Of course, all that application, surface preparation, and application of coatings comes with equipment. Sandblasting equipment, painting equipment, powered by compressors, which we'll get to also later, the effects of those. And then, this is what it looks like. Of course, crude oil storage tanks, nice clean surfaces are always easier to do than angular areas, which bounce all over the place. And then we're also getting into the part of application. How good is a job really depends on the applicator, how well he's going to hold his gun, what is the angle, what is the distance, is the coating going to flow into the pores of the steel, is the coating going to fuse together, or are you going to get that nice film, and at what thickness? It's very important, because if you don't get it right, then it will define the lifetime of the coating. During that period, of course, safety. Nowadays, of course, we take care of people a lot more than we used to in the Western world. Unfortunately, 80% of the rest of the world still use T-shirts as filters over their heads during blasting operations, painting operations, etc. So it's still common to see blasting and painting out in the open. And then, of course, it makes a huge difference what kind of work environment are you working in. Are you in an environment where you can actually control where your blast media goes and paint, etc.? Or are you in a module where you have a lot of sensitive equipment as well, pumps, etc.? Is the grit going to get into the pumps, into the vital areas, and cause sometimes even more damage? So these are all the things which are part, of the process of actually getting a coating to get onto the surface. And then how do we know, did we do a good job? How do we know how long will it last? Well, in most cases, time will tell. And sometimes it shows up within a few weeks, and hopefully it's not going to show up in the next 15 to 25 years. Purely depends on a lot of circumstances. But, we do some destructive tests, pinhole detectors to find out, how does it work? The effects of blasting, well, not to get into the details of, the hazards of safety and so on, but, nowadays we're more looking at, okay, let's choose my favorite grit of choice, like most people would be garnet because it's the cleanest. But then you get asked questions nowadays is, where's this garnet coming from? Oh, from Australia, and we made a big pit to get the garnet out, and then we transferred it across the ocean, and now you're getting warned about what are the CO2 emissions, how long, what have you done to planet Earth to get that grit across? And then once you do the blasting and painting, you remove some coatings, sometimes even the good coatings like red lead, etc., that we have to remove. What are we going to do with the waste? And then we brought it from one side of the world so we can dump it somewhere else. A lot of these things are now getting, a lot of attention. How do we dispose of it? And what do we create? And especially filtering is becoming a big issue. There's some countries in Europe that will charge you up to 700 euros per ton just to clean or purify the waste grit to get all the previous coatings out, so you can dispose of them separate, especially if they're chromat 6, red lead, etc. And when it comes to paint, same thing. Of course, we're working on making paints safer for the people, for the environment, the VOC emissions, the heavy metals that we find in the coatings. But then again, the overspray, where is it going? It's going into the nature, not necessarily onto the assets that we are trying to protect the people, protect the equipment as well, etc. And then what do we do with all these contaminated buckets? Just to clean an airless spray, you're going to use 20 to 30 liters of solvent just to clean it up. And then what do you do with that solvent? Where do you dump it? I don't even want to say where it goes. Or, if we look at it, if we had a coating that it is so surface tolerant or doesn't need a roughness, which means doesn't necessarily need grid blasting, etc. Could it be as easy as remove loose rust, loose paint, have immediate adhesion, and immediately if it tells you will it stick or not, and if it sticks, then it'll probably stick over time. But I'll get into more details on that approach of kind of thinking different, because we do need different kind of results. Now we can try and take the existing, we tried with diesel engines, tried to make them more emission friendly, but nothing much happened until they decided to go for battery. And then battery actually reduced the noise levels, reduced emissions in the cities, etc. So sometimes you just have to, we just want paint and coatings to come out of a can, and we need to apply them by brush or by rollers or by spray guns. But we can see even in the car industry nowadays that foils are becoming quite popular, and yet you have foils that are easy to apply, no VOCs coming out of them, and yet UV resistant, mechanical impact resistant, etc. So yeah, it is possible to achieve certain things, but sometimes, we have to get out of the bucket, I guess, to put it that way. So the target of, let's say, creating a new coating, and now I'm talking 90s, late 90s, create a coating that needs minimum surface preparation, which means just change the adhesion mechanism, not to have interlocking kind of mechanism, but a dispersive kind. No surface roughness, that's what I mean. Adhering to most surfaces, so not only the steel, but also coated or, healthy coatings that are there. No corrosion under creep, so you don't want water to go underneath it, or you don't want corrosion when it's expanding. I think the rule was times 10, 1 micron is 10 microns, 10, 100, and then it pops the coatings off. No VOCs, harmless to the people, to the environment, etc. And then, to have a lifetime, because every time, I know it's good for business. I used to be a contractor when you have to do maintenance every 5 to 10 years, same item, blast, paint. But then, what are we doing? Creating more waste and polluting the environment in return. So where can we find inspiration? Chewing gum, we thought, is a good inspiration. You throw it, and I'm not joking, you throw it onto the street, no surface preparation, none of that. You have immediate adhesion, and it will withstand foot traffic. It will withstand UV resistances, the cold temperatures, the hot temperatures. Most countries even banned it, like Singapore, because it's such a nuisance. So there's something in it. It works. At the same time, it delivers health, safety, and all the other aspects. It was an edible product. But of course, just by thinking about it different, already you can achieve something which offers safety for the people, for the environment, and of course an economic aspect, because we know that a piece of chewing gum on the road will outlast the coated part of the road. So how did we do it, or our approach back then was select as many polymers as possible that are available in the market, with a track record, primarily what stops corrosion, eliminate oxygen, and you eliminate oxidation really. So select a polymer that doesn't allow oxygen and water to go through it, to have immediate adhesion of a dispersive kind, so without a roughness, etc., something that never cures, because a coating that never cures will always have that adhesion and the flow, etc. The same reason why we don't apply dry paint, we apply wet paint. But then again, you have also a polymer which is used in the food industry, for example. It is actually used in the chewing gum. It is also used as a sealant on double glazed windows that are filled with hexafluorides or even lighter gases like argon to escape and oxygen not to go in. So food industry approval, etc. So the polymer is there. Track record, That's what you need when you develop a new product. You need at least a track record of the polymers that you use. BASF invented the product in 1930s for other reasons in those times, but at the same time, it was proven that the product, because it has been filtered so many times, removal of free radicals, it actually came to a point where you didn't have to do much to it, and you had lifetime out of it. So in the beginning, make the product, make the compound, pump it onto the pipe, then put a netting to hold it all together, and put mechanical protection. Labor intensive, you don't know, you don't have even thickness. So we thought, okay, let's just put it all into one foil, if we can call it that, where we have the compound, we have the netting, which holds everything together, and we have a backing. And then we add mechanical protection on top of it. That bringing us to, you know, different kind of systems for pipework, structural steel, and then available paste and putties for uneven surfaces, etc. And I'll show you some examples. And the evolution, of course, from having a solution to start underground. We started with manhole covers, and then went onto pipes. And then we started developing atmospheric systems, etc., growing out of it. Now, what are the differences? Of course, these differences are mainly requirements of standards. Standards are minimum performance criteria according to the environment you're in. So, for example, 21809-3 discusses performances of buried and submerged pipes, soil stresses, how does the system work with cathodic protection, etc. If we go atmospheric, of course, cathodic protection is not an issue anymore. We have UV resistances and other parts that we need to conform to. Corrosion under insulation has its own set of standards. Wet substrate, splash zone, again, another set of standards, because you have to apply it on a wet surface. You have to apply it with a high chloride content in salty areas and salty environments, and yet withstand lifetime, but also impact resistance from whatever floats in the sea, trees, branches, but also boats that impact the piles, etc., and so on. Insulation and cladding, which is part of the sealing, so you can actually seal off the cladding for extra lifetime to eliminate the water ever getting into insulation. Corrosion prevention, which is automated, so you can do longer stretches of pipeline, casing filler, and then of course sealing and waterproofing. Now that one is a tough one. There's no real standards. Sometimes it's not even national, it's even regional, and it's also, whether it's a public building or home building, that's a difficult one. So I'll just show you, without spending too much time, just some impressions of where the product has mostly been used, especially in the early days. We started off on pipelines, in the desert areas with high salinity, high chloride content, etc., in the Stopaq desert. So since 2000s, etc. And then, we did the pipes. What about the flanges? So work with the putties or the paste to do that part. A lot of different flanges and components sticking out of the pipe. And that's where you work with the wrapping bands, of course, for flatter areas and circumferential. But when it becomes a little more difficult, then of course you can use the putties or the paste to smooth out the edges and encapsulate everything. Soft product. Yes, it remains soft, but it can be as hard as we need it to be. So we always have this minimum system of, let's say, this non-curing coating, to call it that, with mechanical protection that can withstand, impact from soil, backfilling, etc., or scaffolding. Somebody chips into the system, which will even get to self-healing. But if we have a large pipe with large weight, then we can add extra mechanical protection or weight distribution, so we don't have pinpoint pressure. It's all a matter of doing systems. Offshore field joints, even LNG or LPG storage tanks, high expansion and contraction, plus temperature changes in this, fluctuations. And again, if you have a coating that is almost like a skin. Whether you gain weight or you lose weight, it's always with you. That's the effect that we're looking for. And then these are the field applied automated system for longer stretches of pipes. Doing a lot of these things underground, we thought, well, there's a lot of pipes above the ground. Why don't we start going above the ground? And I think one of the biggest projects we've ever worked on is from Scotland, Moss Moran, the Shell plant, where I think we did about 8 kilometers of pipe work out there, just going from, underground, and let's get into the above ground. So that was about 15, 16 years ago. But, and then above the ground, you also get into the stainless steels. You get into different metals as well. Stainless steel is, it has its passivation layer, which you don't really want to remove. You don't want to roughen it up, so you can put a top coat on it. And yet we know that the pitting corrosion of stainless steel pipes. So even without any special surface preparation, you have immediate adhesion to the surface. And like I mentioned earlier, you always take a patch of the product and you can test whether it sticks or not. Walkways, for example, conductor piles. And again, going back to surface preparation, removal of loose rust and loose paint saves so much time. It also helps you mobilize and demobilize very quickly. When you work in the North Sea in very harsh environments, it's very important, the weather can change in no time. And if you have scaffolding all around, it makes it very complicated and time consuming to set everything up and then take it all apart. So, a lot of the jobs can be done just because of ease of application, just by rope access and, mobilize, demobilize. We're still learning about the product. So what other effects do we bring in? And we get surprised. A lot of these effects we talk about, we didn't design it for all of that. Self-healing happened. We were happy. Sound dampening happened. So we're happy. So there's still a lot of things that, we're finding out 20 years down the line. We're still finding out what else it can do. And this was just a very noisy area. We wrapped the pipes. Actually, we got this job because the surface temperature of the pipework was 95 degrees Celsius, and they needed a coating that can be applied to that temperature. And then once we covered it, it turned out that it reduced the noise levels in the area. And then again, easy surface preparation application allows you to go to, very distant areas. And how large can these areas be? I mentioned the part with structural steel and flat areas. The whole idea was, why can't coatings be applied like wallpaper? So you can have rolls of 300 millimeters wide, prepare the surface, remove loose rust, loose paint, and apply them in sheets one next to another, put a top coat on it, and that's more than enough to do it. Flanges, all kinds of different parts for corrosion and the insulation, of course. The underneath part, we have the standard system of wrapping band plus an outer wrap. Insulation, once the cladding goes on top. On top of insulation, we also have sealing materials like insul wrap that can, even if something happens to the cladding and the water goes through, the insulation is still sealed off, because we know that once the insulation gets wet, you lose all insulative properties of it, including heat tracing. Here is another example of what I mentioned: high temperature application. So a pipe 120 degrees Celsius, the next shutdown is 2 years from now, but it's still corroding because of the fluctuating temperatures, etc. So yeah, and this is again learning. We don't sell this product as with thermal insulative properties, but it so happened that we went from 120 degrees of surface temperature with the full system. It dropped by 20 degrees to 100 degrees, which for this client meant they didn't need to install the personal protection on top of it. And then this is above the insulation, the sealing of the cladding, cladded areas, etc. And then from there, you saw these pictures, mostly water industry, oil and gas industry. But we wanted also to offer these solutions for bridges, infrastructure, etc. And then we somehow ended up in the wind industry because we saw that there's a lot of need for coating repair. These are very heavy items that get handled from one place to another, paint chips and so on. How do you fix it? And how do you fix it when you're hanging off the ropes in the middle of the sea? So that was a challenge for us, how to develop a solution. And so we have these so-called easy coat patches, which is a one coat system. So they're already come pre-colored, light gray or yellow for the top or the bottom part. And then, oh, okay, the patches, yes. Sure. So this is an example. They come on cardboard. So with a Stanley knife, you can actually cut out the size of the patch that you need. You wire brush it, patch it, and that's how you do your coating repair. And then we have other systems for irregular shapes. Again, the paste, the combination of different materials. And I'll show you, little by little, you get taken from one area to the other. You start with monopiles, you end up on the towers. From towers, you end up in the nacelle and so on. So this is internal repairs, and you'll find a lot of these damages, let's say, in the around the bolted areas when you use heavy equipment to tension the bolts, etc. And it's now very easy just to patch it to stop further corrosion. Sealing and encapsulating of sensors throughout the whole towers, including the wiring. These are examples of paint chips. Wherever due to handling, you just patch it, really. So not much to do. So you don't need to do surface preparation, primer, second coat, third coats, and so on. Just patch it and it's done. And these are the latest pictures that we got from one of the projects in the North Sea after 5 years in service. So not much of a change. Pretty easy. And then leather stubs, flange sealing, so complete seal of the TP connection. Again, part of the TP. So you have a void. Obviously, we know that is bound to be corrosion in that area. So with a combination of paste to seal off that the edge, and then the patch just over it in the color. So it's a two-step system, very easy to do. And training can be online, and within a few hours, you're a perfect applicator. ICCP flanges, so all different components. And this was one of the bigger projects, which was for this special design of windmills, slip joint windmills, where instead of bolting them together, you put the monopile in and then you slip the tower on top of it. So to seal those areas from the water going underneath and creating corrosion, etc., we create these seals, the green one over there that you can see. And then when you slip the tower on, it smears out the product and seals it off from the environment. And one of the latest projects that we've been working on was, in fact, sealing on substations. They're all made of sandwich panels. And of course, these locations are always very windy, and that wind eventually, just by hitting these structures, the sandwich panels become loose. And soon enough, the rain, the water, the wind, the salty air is getting in between the voids. So, we've been sealing off those areas now as well to prevent further access. And then, of course, that came from this as well, which is the new design of towers. Well, it's not new, it's a few years old, but now being adapted, which is very similar to the tower design of the windmills. So same kind of design they are now working on with internal flanges for high voltage power lines transmissions. So that was the easy code part of business. And now back to what I started in the beginning, which was, okay, corrosion, yes, it stops corrosion, very good. We've been doing it for 20 years, so I think we've proven that part, that the system actually works. But what else do we bring in? And that's what we try to focus. What does this minimum surface preparation bring? That, you know, you can hear examples of different surface preparations, even smooth, where you have stainless steel or carbon steel, but also preparations with an abrasive pad, with a brush, foam, etc. And the product, because it doesn't change over time, you can use it as your quality control check. Does it stick or not? And like I said, if it sticks now, it will stick over its lifetime. This is what a setup looks like. We pack it in roll forms, so it looks like a tape. It has nothing to do with the tape because you pre-cut sheets and you put them one next to another, or you can roll them out like wallpaper, like I said, for straight sections. Mostly you just need a pair of scissors to cut it to shape. What you do is you remove the release foil, then you get to the adhesive side and you just lay it on. So what is the cost for all this? We always get asked this question, how much for all this effects? Of course, quality doesn't come cheap, that's for sure. So this is a comparison that we've been working on with different contractors, but also end users of, you know, what is the cost of paint? And I'll actually, 2 slides later, I'll actually show you an absolute price comparison in numbers, in euros, not in pounds, of the effects. But we have to look at the whole big picture, because if we want the paint to work, we select the best paint, and we went through that process. We select the best paint. The success of that coating, 80% depends on surface preparation and application. That's also the risk. If something goes wrong in that 80%, there goes your coating, even if you went for the best one in the world. And I've seen best coatings fail, and I've seen mediocre paints work because somebody actually spent time to apply them properly. But you know, in general, we have to look at all this. What is the cost of all these things, but also what is the cost over time? What is the lifetime of this? Is it 5 years, 10 years, 30 years? It makes a huge difference, especially on the impact of onto the environment. So this is something we worked in with some of our clients in the North Sea, especially where the rules and regulations of waste management are getting more and more stringent. You can't go to an offshore platform now with 2 tons of grit and come back with 0 tons of grit. You actually have to bring it back and prove that you didn't chuck it into the sea. So, you know, they looked at these comparisons. Okay, what do we get with that minimum surface preparation or that full surface preparation that certain, you know, the older systems need? So this was a comparison of blasting and painting just in grit. To do 100 square meters, you're going to need about 2 tons of grit. I think it was, I can't see it now. I think it was 100 square meters. Plus all the other stuff that you need that goes with it. Meanwhile, with Stopaq, no paint cans, no cans around. Something you actually have cardboard, which holds it together, and the release foil, both recyclable, easy to dispose of. And, you know, it's just 15 kilos. So there was already the big difference. But then it was, what about carbon emissions? Because if you don't have to blast, then you don't need compressors or other things. So you can reduce carbon emissions up to 90% in this study. Safety-wise, of course, not even talking about it. You know, do we want our applicators to be in contact with something where they need masks, breathing apparatuses, air feeds, and so on, or do we want something which actually has a drinking water approval or contact, you know, with skin? And then, of course, we looked at what is the performance, and the performance. If you get 30 years, you gain a lot more out of it, because otherwise you have to do it 3 times. It depends on the location. You know, if you're close to the sea, if it's an offshore platform, or if it's inland, this interval for maintenance interval can be anywhere from 2 to 5 years. 5 to 10 years, depends where you are, but still it's a big cost. And when it comes to actual cost, this is a comparison when, of course, there are a lot of systems that stop corrosion. And you can stop corrosion with WD-40, with some grease, but then we get high tech, we get into coatings, zinc phosphates, butyl rubbers, all these systems, stop corrosion. The whole difference is what does it take to apply it and how long will it last? That's the key thing. So this was a comparison with North Sea approved systems. An epoxy system, some of the best is between 8 and 10 euros per square meter. So primer, second coat, and third coat, versus here with this system. Now, of course, Stopaq has multiple systems depending where you apply it and what is the application, what is the resistance you're looking for. This is versus 100 euro per square meter. So 10 times the difference in cost of material. But what does it take to apply one? What does it take to apply the other? Blasting, no blasting, minimum surface preparation speed, etc. Because, so related, we saw that you can apply it at high temperatures, so you don't need to wait for shutdowns and so on. There's no evaporation or curing process, which means 85% humidity is not so much of an issue, etc. So when you take all these operations into account, yeah, you've spent on an 8 euro system, you spend 200,000 euros on actually applying it and so on. And meanwhile, on the other side, you only spent 130. Yeah, the numbers are a bit small. 200,000, 130,000. We can say saving of 70,000 for 500 square meters, or with some people, it means more for the budget. You can do more items. So yeah, that's the story of Stopaq roughly. Along the way, of course, what are we doing? We need to show the people that there are different ways of stopping corrosion, the different approaches. And yes, it's always been done that way. I've seen, especially when I was a contractor and then working for engineering firms, the copy paste, the speed of just getting next project, copy paste, change the name of the project, change the name of the client, everything else remains the same because we've done it like that before. So it'll probably be good for the next project and the next project. I've seen it all too many times, but nothing changes. We keep on running in circles. The pandemic was great, I have to say, in that perspective, because I could see some of the clients actually sit down, not under pressure of new projects and so on, actually rethink, what are we doing? Are we doing things correctly? And a lot of these calculations that you've seen, actually, they did come in the last 2-3 years during this period of people rethinking. So there is a positive change. But, we've always done it this way. Yes, we've always, even at home, we always used to dump all our rubbish into one spot. Now we're segregating. So there are things that we're going to have to do, in the industrial world, just like we do at home and so on. So, to change their perspective of why are we doing things over and over again if it's not good for anybody at the end of the day. So, yeah, that's it for me. So, yeah, if there are any questions or something, please.
Yeah, you touched on it, just the speed of application sector. I did also there, I didn't pick up on it. Chemical resistance, and then that leads on to
Yeah. Well, it depends. We don't do linings. So internally, we don't do. We only focus on external corrosion. As linings, it could potentially work, but then we would need a top coat or something that could withstand. So even though Stopaq has high pH resistance, let's say 2 to 14, that one is fine. And actually comes from polyethylene family. It's the amorphous part of polyethylene. So roughly whatever polyethylene can do, polyisobutene can do, and therefore Stopaq can do. So if that's a guideline, but when it comes to chemical resistances, we prefer to know what is the chemical, especially chemical combination, chemical mix, and then we tell you.
Yeah, hi. The practicalities of life in a refinery or a live asset, where product, and it can be anything, you know, the spillages and then any detrimental effect, and you know, is there a likelihood for you know, having to, you know, cut out and repair, etc.?
Well, yeah, we don't know all the combinations, so there could be damage. It is highly resistant to chemical impact, yes. And then again, both acids, alkalinity. There is an outer wrap. There are top coats, so it's always a system. You'll barely see Stopaq just on its own out there. So the top coats and so on will withstand. But if there's any damage, it's very easy to repair as well.
Okay, that's great. And the only thing you need to get it to do is to get it to inch mess, and I think that you're on to a winner.
Well,
Seriously. Yeah, is that something up your sleeve?
yeah, but I can't speak about it. Yeah. Not publicly, not online.
Okay, are there any more questions from our audience today?
Approvals?
Yeah.
Oh, plenty, yes. Well, you can imagine how easy it was for us in the last 20 years, especially the early days, to get this technology in. It actually went through long approvals, especially for the underground and subsea. People are more comfortable in trying innovation when something is accessible or above the ground. But when you do underground, it's going to get buried and who knows what's going on. So of course, a lot of approvals, it all started more or less with Shell because we are a Dutch product, and then Shell took us to Oman where they had a lot of problems. So some of the first applications were in Oman, then we went to Saudi Arabia with Saudi Aramco. So a lot of approvals, a lot of testing done. We didn't create this coating to conform to a standard because it is non-conformant in such a way. So it took a long time also to get it into the standard. So now there is a standard 21809-3, which has, you know, which is made for this kind of technology. That took 2 years. But yeah, a lot of testing.
So that's the field joint coating standard.
Yes, that's the field joint coating
Does
standard.
it also do the cohesive adhesive test? I mean, does it pass that as well?
Yes, actually that test, which is really made for this technology, the test is, yeah, the pull off, and then you need to have a minimum 95% cohesive fracture. Yeah, so the whole system is designed, and that's where that viscoelastic part comes into play. The system is designed that the adhesion must be stronger than cohesion. So you can never really take it off. It's like if you have a pool of water on the table and you try to lift it, you can't. You lift bits and pieces. So the same way the system works. If you are more on the elastic side, then you get into the point where your cohesion is stronger than adhesion. And then when you have soil stress or some other kind of movement, you can actually rip it off. And when you have too much elasticity, you actually transfer the external forces down to where you don't want it. I almost want this slimy layer, which is working on the pipe.
How does that stick to other coating products, 3-layer systems?
Well, it sticks to polyethylene, even without roughness, of course, polypropylene. Actually, the smoother, the better. So it will stick to glass faster than it will to a roughened surface using sandblasting, because creating a roughness is increasing the surface area. So the more surface area you have, the more it needs to flow in to fill those voids. When you have glass, you will have immediate adhesion. So yes, polyethylene, polypropylene. How do we get it off? Well, silicone. Silicone does the trick, so it doesn't stick to silicone. So all these, let's say these sample folders and so on, they're siliconized release foil, and that's how we can get it off.
Okay, we have time for one more from our audience. Okay, perfect. We'll have some questions from our online audience. So I'll just read them out if that's okay. Okay, so first question is, what are the benefits of wrapping flange connections?
Well, the way the system works, you encapsulate it from the environment. So, if you're tensioning the bolts, for example, you'll crack the paints and etc. And then here you, with the use of pastes and wrapping band, you encapsulate everything, and then yeah, it's safe from the environment
Okay, perfect.
as a permanent kind of fix.
Okay, the next question is any surface preparation testing needed before application?
Yes, and that's the adhesion check that we use. So you take a patch of the material, you put it onto the surface, and you try to peel it off. And that's where we do the cohesion part, where it has to cohere. That will tell you two things. It will tell you whether the surface is clean enough. If it comes off, either you're going to see dirt on it, or if it comes off, it means there's humidity on the surface, the dew is too high, or there's some other contamination interfering. But yes, you use the product to test.
Okay, thank you very much. Next question is, has this product been used in the UAE?
Yes, very much so. Yeah.
Okay, nice and quick. Next question is, how resilient is Stopaq to cathodic despondent?
Well, because of the self-healing part that I mentioned, didn't talk about it too much. It is because it's a liquid system under tension from the outer wraps and so on. If you bury it and you puncture it, it will self-heal, which means the cathodic protection will work for that part while there is an opening, but then as it self-heals, it will just go back to normal. But of course, part of the ISO 21809, there are also such tests being performed. Compatibility, yes.
Oh, excellent. Thank you very much. Okay, next question we have here is, can Stopaq arrest corrosion if applied over an active corrosion site? Or does any existing corrosion have to be arrested prior to its application?
It can arrest corrosion, obviously. We've done extreme tests where we just seal off the edges, even induce air or water by an injection. What happens is there's a corrosion cell. Once you run out of oxygen, the corrosion cell stops because you don't have more replenishment of oxygen or water. Yeah.
Okay, thank you very much. Okay, so we got two questions here that I can combine into one. So the first one is, once the system is applied, how can the asset monitor the external condition of the area that has been wrapped? And the next one is, how can they do NDT over? Can they do NDT on the wrap as well?
NDT. I did mention a little bit about sound absorption. Sound absorption means absorption of waves and sound. Ultrasound, for example, is a sound. It will absorb it. You can't do UT through Stopaq. It will absorb the sound. X-ray is fine. Eddy current is fine, but UT no. So what we usually do is how to check what's going on underneath Stopaq is either remove a patch, scrape it off, do what you have to do, check if there is corrosion or not. That's what was the other question? I think there was an add-on.
I believe it's how can you check the external condition?
External condition. Well, of course, you can do that by opening it. But now we also work with a company called InductoSense that has these sensors that you can actually put underneath Stopaq that measure the thickness of the steel. So you go with a wand, you hover over the pipe, and it can give you a reading. So you have constant reading of what's happening underneath Stopaq. Yes.
Oh, that's fantastic.
Yeah.
Thank you. Next question is, how easy is it to repair damaged coating?
Easy. Yeah. Like I said, if it's really bad, you can cut out a bad piece, put another patch on it and wrap it if you're using wrapping. If you're painting, same thing, just put another patch on it and top coat it. So very easy to repair, small or large.
Oh, that's good to know. Next, what is the maximum temperature this can be applied?
120 degrees Celsius. That's also the maximum operating temperature.
Perfect. Excellent. Okay. Next, on slide 15, you had a VOC. What is the meaning of that acronym?
Volatile organic content.
Thank you very much.
Phew. Imagine I failed that one.
Okay. Next question we have is, what is Stopaq's capability for subsea application?
Subsea application. Oh, applying it underwater.
Yes.
Yeah. So we do have a specialty. I mostly showed the products that are applied on dry surface, but we do have a product that is applied under tension as water displacement. So you displace as much water as possible, and then it has water absorbing capacity. So it absorbs some of the water through secret ingredients, and then it stops corrosion again. Yes.
Okay, I guess that somewhat answers some of the next question, which is how dry does the surface have to be for application?
So for the dry system, same rule, 3 degrees above the dew, it has to be. But we do have this specialty product, which is called WSH, wet substrate H for high temperature. That product can be applied in submerged conditions, immersed, and also on condensing lines, for example, etc. Yeah.
Okay, that's good to know. Hopefully there are not too many more of these, so please bear with me. Okay, another acronym question. What does PIB stand for? PIB coating.
Polyisobutene.
Thank you very much. Next one we have is are salt tests required prior to application?
No.
Nice and simple, thank you. And next, what's the minimum temperature under zero Stopaq can be applied to?
We have 3 grades, which means 3 different viscosities. So our CZ grade can be applied around 0. I mean, I've managed to apply it sub-zero as well. But let's say, so you can apply it at low temperatures, but its maximum operating temperature is 50. And let's say the 120 is the stiffest, but it needs a higher temperature for application. Yeah.
Okay, thank you. And here we go. Just a couple more. What is the preferred training route, online or face-to-face? And what is the average cost of your online training?
Average cost of online training is, I think, 950 euros or something for a group of 4 to 6 people, onshore, not offshore. It is possible to do it online, especially, and we did it for COVID times. We also made quite a lot of application videos that are available on YouTube as well, how to apply a flange, how to apply a straight pipe, and so on. But for certification, of course, we prefer to have one-on-one training just to make sure. So we do provide certification as well for the applicators. Okay, excellent. And just one more question for myself. So how can people get in contact with you if they want any more information on this product? Well, in the UK, of course, Scotland Stewart is here with the contact details, and globally, of course, through the website, info@sealforlife.com is always open. So, yeah. Okay. And I don't know if you can share my contact details as well. Yeah, they will be available also. Okay. Thank you very much, Dinko, for answering these questions, and thank you for an excellent presentation.
What's the lifespan of the product in different environments, like atmospheric or subsea and other?
Lifespan. We designed it, well, that's what we say. We designed it for a minimum of 30 years. That was always our target, because we also looked at it during the development phase. If most of the coatings have a lifetime of between 15 and 25 years, we're not going to make another one of those. So we decided, okay, let's make a 30 plus. Based on the polymer that we use and the lifetime and the track record that we have of the polymer since 1930s. So we're quite with no change, and we make sure that the product that we do not affect the polymer that we use. So we stabilize it because it's a free-flowing material, and we don't want it to free flow when preventing corrosion. So, you know, we withstand that stability of the polymer, but yeah, 60 plus years. That's
interesting. Yeah. So in terms of the lifespan, in terms of the quality and the cost effectiveness, it seems like very good solution.
Seems like a perfect coating, right?
So
it probably is.
So why is it not more widely used in the industry than as opposed to the conventional coatings?
There is a lot of, good question. There's a lot of, we've always done it this way. Lack of understanding. What are we actually doing? And I'm not blaming AMPP and SSPC for that. But yeah, sometimes people get all these CIP parts and so on, without actually understanding what are we doing, how are we actually stopping corrosion and all these procedures. Yes, what to follow to get the best results. Yes, but what are we doing? And then if you don't understand how you stop corrosion, then it's difficult to absorb some new information or a different approach. But I have to tell you that there's a lot of, I'm not going to say politics, that would be the wrong thing, but what did I do? I showed you the benefits of reducing surface preparation by removing blasting. So you can imagine there's 80% of this industry with, I showed 80% dependency on the coating. Well, now 80% of the industry is not happy with what I just said, which is, you know, the waste management. What about the grid providers, the equipment providers, and a lot of the contractors that actually apply this? They don't see, you know, they earn money on surface preparation and application rather than the product at the end of the day. So yeah, but the mindset is changing.
Yeah.
Everybody can see the benefits. So yeah, it takes time for acceptance. Yeah.
Thank you.
I think you'll find in Australia, for example, the product
Okay.
has a very good.
Thank you very much.
Yeah, welcome.
So I think that's all for this evening, and we still have 15 minutes by. I just wanted to mention about the next presentation, which, as I mentioned, will be again hybrid session in Palm Court Hotel. The topic is about safety and environmental critical elements. Will be presented by PIM, Plant Integrity Management, in Aberdeen in Palm Court Hotel. Again, thank you for coming tonight, and thank you for online attendees joining us. Have a good evening. Cheers. Thank you.
Thanks, Human. Thanks, Ollie. Thanks, Stuart. Dinko, very well delivered. Thank you.